sorry for this late report. This report is about the extractions of caffeine from the tea leaves. For the glassware equipment, we need the following: water flask, condenser, so for the chemicals, we need dry tea leaves, methylene chloride, and 2 kind of anhydrous sauces. In the dry leaves, caffeine is the main components here. So caffeines, which possess mildly addictive stimulations and excessive consumption of caffeine could cause rapid heartbeat, irritations of the stomach, etc. Dichloromethane, it could cause like eye, skin irritations, kidney damage, and possible cancer hazard. So these 2 anhydrous salts, they have some hazards in case of skin-eye contact, of ingestions and inhalations. They could be disposed of in the trash after we let the organic matters evaporate out in the hook. And methylene chloride should be disposed of in the halogenated organic compound trash can, waste container. Alright, decaffeination. Because of the too much caffeine consumption will kill you or having several serious health concerns, a lot of people favors decaffeinated drinks. Decaffeinated drinks are not really caffeine free right now. Only 97% of the caffeine could be extracted, even with the advanced technologies in here. The industrial direct decaffeination process, they also use the methylene chloride that we use in the lab. Methylene chloride like washes repeatedly the coffee beans or the tea leaves to extract the caffeine from it, like really wide used. However, like dichloromethane have some kind of carcinogenic effects for humans and like some kind of health problems. Right now, they substitute the supercritical carbon dioxide in some of the decaffeinated process right now. Okay, after we get the dry tea leaves, we start the solid to liquid extraction. Here goes. The tea leaves were put in here, and then the sodium carbonate anhydrous sauce is also put in here to dissolve and to create the basis environment where chemicals in the tea leaves other than caffeine will not be extracted in that concentrated tea. The water is let wide and the condensers like recollect all those evaporating water molecules to make some kind of concentrated tea. The mixtures of the tea leaves and then the water, like with the caffeine, of course, will be like filtered with the vacuum filtering device right here. And after we get the aqueous concentrated tea, we put it in the separatory funnels to extract with the methylene chloride right here. You can see the separate organic layer right here. However, due to the natures and polarities of the caffeine, caffeine could a little soluble in room temperature water. In other case, like really soluble in methylene chloride. However, caffeine is soluble in both kind of, so it will cause some kind of immersion here. So we could not possibly separate because of all those mess up. So we have to put it into the centrifuge tubes and make it all separate out clearly like that. And then we collect all those organic layers in one of the aluminium flasks. Well, after we collected the organic layer, we have to purify the caffeines in methylene chloride by like evaporating out the methylene chloride with a hot plate. And then we get the really crude caffeines with some kind of tannin and stuff in it. Caffeine tend to do sublimation, so like we could purify caffeines with sublimation. So for sublimation, we need a flask with the vacuum tube in it, filtration flask. So some kind of test tubes, centrifuge tube, if you will, and a banner. For the sublimations, we need the high temperature from the banner and then low pressure for which we get from the vacuum. And then to recrystallize caffeines like on at the bottoms of the centrifuge tube, we put some ice in here so that we could collect those caffeine here. After we have the purified caffeines, we put it into the melting point device to determine the melting points of the purified caffeine. However, caffeine tend to do sublimation rather than melting, so we have to burn both sides of this melting point tube to treat the caffeine into melting. You need to record the range of the temperature from starting to sweat to complete melting of the caffeines like this here. And this is the data, the masses and the melting point. From what we get like the mass of the caffeines, which is really low because of some errors in my procedure. And then the percent recoveries of the sublimation, which is also very low because of some unavoidable errors. So this is the degree of the caffeine. The HNMR prediction. The prediction is based on this molecules attached and those double bonds surrounded the hydrogens here, like the beta carbons. These are all like different attachments, so they will have like different signals and different things. This have one hydrogen here, so in case you miss it. Questions. The questions state that to compare and contrast the eugenol extractions and caffeine extraction. In this case, eugenols need the simple distillation process using steam to trick the eugenol into evaporating so that it can be extracted. However, in caffeine case, caffeine is really soluble in hot water, so we just need the hot water to make a solid to liquid extraction, which is really simple, just making a tea, but concentrated. In here, eugenol is like really oily substance that's not soluble in water at all, so we don't have the problems of immersion going on. We just need to extract it really quickly with the methylene chloride. In this case, caffeine is some kind of emulsifier and soluble in bulk substance, so it will be a little bit of immersion going on, and then we need to separate with the centrifuge tubes and centrifuges and all the stuff. And then this is the eugenol is a liquid and caffeine is a solid powder, so that's the differences. Similarities is just like you have to use methylene chloride to extract because of the both of them are really soluble in organic solvents. So errors. First, some kind of avoidable errors. During the procedure, a lot of people don't know that you have to use the vacuum filtration flask to collect those methylene chloride and caffeine. So I'm also collected in a regular aluminium flask and evaporated out. But then uh, to make a sublimation, we need to change the flask. During the changing of the flask and stuff, I drop a little, so kind of the stuff in the flask broke and the caffeine is lost here. But luckily, I am able to like collect a few of it to test later on. And then in here, there's some kind of avoidable error that the procedure state we need to refurnish the water. However, I think I might have put more water than necessary, so my caffeine doesn't look like really concentrated. It has a lot of water in it, so it might have affect some of the caffeine extracted here. An avoidable technical error is that during the sublimation process, the percent yield will be really low because some of the sublimated like recrystallized caffeines will go into the tube that connects it to the vacuums, so we cannot retrieve it. So this is some technical error that you cannot avoid. And this is the reference page. Thank you for watching. Enjoy.